Good afternoon, everyone. My name is Sanjana, and today my topic is single phase induction motor. And in this, we're going to learn the construction and working. So, without further ado, let's get into the video. So, we all know that a number of appliances around us, like fans, washing machines, and dishwashers, they're all powered by electricity, and they're made in such a way that they're easy to use and are cost efficient. So, such is a single phase induction motor. They are easy to use and are cost efficient, and their applications are in a large number of home appliances, with it having so many advantages. We'll learn more about the construction and working. So, in single phase induction motor, it converts electrical energy into mechanical energy. So, it consists of namely starter and motor. The starter is a stationary part of the motor. It has laminated sheets that are powered with holes. These holes are arranged in such a way that the windings, the laminated sheets, are the reduce eddy current loss. So the starter consists of main winding, via which a single phase AC supply produces an AC magnetic, an alternating magnetic field. In the main winding, this alternating magnetic field gets induced in the rotor, like this. So this alternating magnetic field gets induced in the rotor by the principle of electric magnetic induction. The rotor now has a magnetic field. Now, according to the Lorentz law, the electrical and magnetic field will develop a force by which the rotor must rotate. However, that does not happen. The alternating magnetic field produced in the rotor makes the rotor rotate instead of vibrating in a fixed position. Double revolving field theory, which states that the alternating magnetic field is a sum of two equal and opposite rotating magnetic fields. The two magnetic fields, being equal in magnitude and opposite in direction, do not provide the rotor. This is like holding a book from two ends and pulling it yourself. The force applied by you is equal both sides but opposite in direction, and hence the net result is zero moment. So, starting torque to the motion. So, this is done by bringing another magnetic field that will help reduce the starting torque required for the movement of the rotor. That is achieved by adding another wind called auxiliary winding. So, the auxiliary winding, which is placed perpendicular to the main winding, the auxiliary winding is connected to an AC source and produces two magnetic fields like the main winding. These are the two magnetic fields. So, produced by the auxiliary winding, one pair of magnetic field being opposite to the main winding gets cancelled. So, this one gets cancelled, while the other pair adds up to the magnetic field of the auxiliary winding, giving the required initial torque and making the rotor rotate in one direction. So it rotates in one direction. So now, even if the current in the auxiliary winding is cut off, the rotor will still rotate because it has the initial torque required for motion. The auxiliary winding is cut off by a switch. This is the capacitor. So a capacitor is connected in series with the auxiliary winding This is done to keep the auxiliary winding at 90 degrees phase difference from the main winding, which helps in achieving our aim to provide the starting torque to the motor. This is how a single phase induction motor works. Thank you, Anand.